Hey guys, alright, this is the recording for 4.4. Now the title of this is called Modeling and Optimization. So optimization is either making things for its best. So if we're talking about cost, then we want to optimize cost, and how would we do that is to minimize cost. Now, and if we're talking about profit, then to optimize that, then we would like our profit to be the best, the most maximized profit. Okay, so it depends on what kind of problem we're given with. Okay, so here's example 1. A, what is the largest possible area for a right triangle whose hypotenuse is 5 centimeters long, and what are its dimensions? So for this one, we are interested in, oh my god, this is really big. Okay, interested in largest possible area. So largest area, okay, and then we're interested in dimensions. So dimensions for this one is talk about right triangle. So it's really talking about length times width, or base and height. Okay, so dimensions. So largest area. Now if you hear noises, that's just probably my husband and my kids. Okay, largest possible area for a right triangle. So what you want to do is you want to draw this out. All you are given is just 5 centimeters for the hypotenuse. Okay, so let's call this base and height. So B and H. Well, area, as you already know, it's always 1/2 base times height. Well, there's not much else you're given to go with, right? So let's just make this equals. How about that? Well, but there is a relationship between B, H, and 5 centimeters. That's a right triangle. So we are talking about A squared plus B squared equals C squared. This is Pythagorean theorem. So A squared, we have B squared. H, we're going to use for the B. And then we're going to have 5 for the hypotenuse, which is C squared. So right now, all you have is B squared. What I'm going to try to do is I'm going to solve for B. Okay, so this is 25 minus H squared. So B is technically plus or minus square root, but because B is a base, which is the length, it can't have a negative, so we're just going to keep with a positive radical. So in my area formula, I will now try to keep it with respect to H. So area in terms of H, which is 1/2. Since I've solved for B already, I'm going to plug in 25 minus H squared. Okay, now I'm just going to rewrite this really quickly as 1/2 H in the front, so the radical maintains in the back. So this is the area with respect to H. Now you can also do the same thing with B, or the base, right? You can write the area with respect to the base. Well, as you know, the derivative, we have been studying derivative pretty much ever since we started second semester. The derivative allows you to find, the first derivative allows you to find the turning points, right? Now, turning point is either at the very top, or let's call it local max, or the bottom called local min. Well, that's where optimization is going to be, okay? At the top or the bottom. So I would now need to take the derivative with respect to the height, okay? So I'm going to have to use a product rule. So it's going to be 1/2. Drop this down, then I'm going to add the derivative of 1 plus H under the radical, take the derivative of that, and then carry this over. Okay, so let's try to do this nice and neat. This requires you to have 1/2. This maintains as a 1 minus H squared. Now I'm hoping by now you're pretty good at taking the derivative radical stuff. So 1 plus H squared to the -1/2. Chain rule said I need to multiply. Oops, why am I doing negative? Chain rule says I need to multiply by that. Okay. And why do I have one other son? Oh my, this is bizarre, right? Why? How did the 5 becomes 1? Jeez, sorry. Okay, 25. 25 minus H squared. 25 minus H squared. All right, let me just make that. Where did the 1 comes from? Oh man, my brain is just 25 minus H squared. And this is 25. Let me just erase it. Sorry. So the derivative of that is no longer. I just totally messed that up. All right. Derivative of that is 25 minus 8 squared to the negative half. To the negative half. Let me just make this pen a little bit not as thick. And then times the change rule, which is negative 2h, and then drop my 1/2 h down. Okay. Wow, sorry about that. So this is 1/2. I'm sort of trying to make it pretty now. Okay, so I got h times h is going to be 2h squared. The half and the 2 cancels out, so now I have a negative h squared, and then I have a half, so that goes in the bottom here. Okay, then I'm just going to write that negative radical here on the bottom to make it a positive radical. Okay, I'm going to try to find a common denominator. So once I find a common denominator, that means I'm going to multiply this side by 2 rad 25 minus h squared. So that means the top now cancels out. Okay, so I will now, actually, you know what, on this side, let me do this so I don't have to worry about the 2. Would you agree? I'm going to write one more step so you're not totally confused. Would you agree the 1/2 on the left hand side, I can technically just write 25 minus h squared over 2. The reason is that way I don't have to worry about multiplying the 2 for the common denominator. Okay, so this is what I'm doing. So now I can multiply by the common denominator of this. So with that said, that allows me to, on the top, I would now have 25 minus h squared. Now minus h squared all over common denominator of 25 minus h squared. I'm going to try to combine like terms. So this is 25 minus 2h squared all over 2 times 25 minus h squared. So this is as pretty as I can make it. So I would like to find the critical points. Okay, so I'm going to take the numerator and I'm going to try to set equals to 0. Okay, so the numerator, I'm going to solve for 0 from the numerator. So that's 25 minus 2h squared equals 0. That is 25 equals 2h squared. That means h squared equals 25 over 2. H is a height, so I don't need to worry about the square root of a negative. So this is 25 over 2, which is 5 over rad 2. Okay, so that's what h can be, 5 over rad 2. Now, as you can see, that's all I have to do right now. Now I need to find, that's what h is, but I need to find the dimension. So I also need to plug it in and solve for the base. Okay, so I need to solve for the base. So plug it in, solve for the base, and I'm gonna drag this over. So this is what h is. Okay, h is gonna go over here. Okay, all right, so here we go. Base is square root, okay, h squared, it's already 25 over 2. So what I'm gonna do is I'm gonna minus 25 over 2. 25 with denominator 2 is now times out by, that's 50, right? So would you agree that, ooh, that's also square root of 25 over 2, which is also 5 over rad 2. So the base and the height happen to be exactly the same. So let me, dimensions are 5 divided by radical 2 centimeters by 5 divided by square root 2 centimeters. And no, you do not need to rationalize your denominator. So those are my 2 values, okay, that will give me the largest area. Then I just have to plug it back to my area formula. Oh my gosh, that is some fat tip right there. All right, so area is now 1/2 times 5 divided by rad 2 times 5 divided by rad 2, which is 25 over 4. Okay, so it's going to be 25 over 4, and I'm just going to write 25 divided by 4, and because it's an area I need square. So those are the answers to my application here. So the largest area is 25 divided by 4 centimeters square, and the dimensions are 5 divided by rad 2 by 5 divided by 2 centimeters. Okay. All right, here we go. Let's do part B. What is the largest possible area for the rectangle whose perimeter is 8 meters? And what are its dimensions? So again, these kind of problems are asking pretty much the same thing. So we are looking for the largest area again. And we did this already in pre-calculus at the very beginning. This is pretty much our first unit. And now we're just doing it again using derivative, because in first semester we did it using a calculator. Okay, dimensions. All right, so largest possible area for the rectangle, and I tend to draw a rectangle or whatever shape that we're working with so we have an idea of what's happening. Okay, oh, let's use width and length. How about that? Length, oh no, the length's at the bottom. Width and length. Okay, again, area is length times width. Perimeter is going to be 2L's plus 2W. In this problem, they gave us 8 meters as the whole perimeter. And similarly, I'm going to solve for one of these variables. So let's just solve for L. Okay, so 2L equals 8 minus 2W, dividing by 2, so there's going to be 4 minus W. This is what 1L equivalent to in terms of W. So what you want to do next is you want to rewrite the area, okay, in terms of whatever variable you want to use to work with. Well, since I solve for L, so this is the area in terms of its width. Okay, so I'm taking out the L and I'm going to substitute it with 4 minus W. And no, you don't have to make it pretty, but I will because I know I'm about to take the derivative. Okay, the derivative of A, which is area, okay, with respect to W is 4 minus 2W, and I want to set it equal to 0, okay, because I want to find the min and the max. All right, so we are going to solve for it. So we're going to go 4 equals 2W, and W equals 2 meters. So I have my W. Okay, dimensions are 2 meters by, let's solve for L. So L is 4 minus 2 equals 2. So by 2 meters. Okay. Now the largest area, well, that's pretty easy because area is just going to be length times width, which is 2 times 2, which is 4. We're dealing with meters, so we're going to use 4 meters squared. And this one is not as bad because the numbers are really nice. Okay, now let me just try to graph. Let's just say I want to graph out 1A just to see if we are correct. Keep in mind that we already had this area formula right here. Okay, so what I'm going to do is I'm just going to graph that out on my decimals and then see if we would have something similar to 5 divided by rad 2. Okay, or 24 divided by 4 centimeters squared for the largest area. So let's go to decimals really quickly. All right, so in decimals, what I'm going to attempt is to graph out half h times square root of 25 minus h squared. So again, half h. Okay, so let's graph this out. Decimal. Oh, where's my Google Chrome? There you go. 0.5x times square root 25 minus x squared. Okay. So now we are talking about a maximum area. So obviously, number one, you can't have negative dimensions. So anything on the left-hand side of this, you can totally ignore. All you need to do is focus on over here. So it looks like your maximum area is 6.25, okay, which is the y value because I'm graphing this in terms of area. Now let's go back to my calculator if I know where it is located. I am terrible at using my Surface Pro calculator. Okay, remember the calculator was 25 divided by, was it 4 or 2? 4? Let's look back. I forgot what was it. What was the max area? 25 divided by 4. Okay, 25 divided by 4. So let's find my calculator again. Oh, nope. Whoa, sorry. Dang it. No, I don't want a calendar. I want a calculator. Okay, calculator. There you go. So 24 divided by 4. I just multiplied, didn't I? Lame. Sorry. All right. 24 divided by 4 equals. Okay. Was it 24 divided by 4? Oh my gosh. What am I doing? 25 divided by 4. Oh, jeez. Okay. I know. I am not really... Okay. Not having good luck here. So again, 25 divided by 4. Okay, is 6.25. So let's go back to my decimal to see if it comes out to be pretty... Look, 6.25, right? And then remember, our dimensions were 5 divided by rad 2. So I just want to confirm that really quickly, if I can hit the calculator correctly again. So clear that. 5 divided by square root. Oh, you know what it does in this one? It does the radical first. Okay, so I'm going to do radical 2 first. 2 radical, which is that piece. Then I'm going to do 5 divided by this piece equals. Did it do it? Oh, it didn't do it, huh? Dang it. Okay. How would I do this? Okay. I'm going to try my best to see if I can do this. 5 divided by, open parentheses, 2, and then radical. Whoa, there you go. Close it up. Yeah, baby. All right, 3.5355, okay, which is a number that we did see on my decimal, okay? So we're going to go back to decimal. Yeah, okay. So so we know we are on the right track. And that concludes this video for this example.